Hello children, how are you all? Welcome to digital classes. Children, in this lesson we will be studying about pure substances and mixtures. Children, salt is a substance we use in our daily life. It gives taste to our food. Sugar, we use it daily in our lives because it gives sweetness. Then salt and sugar, are they pure substances? So in this lesson we will be studying about, is matter pure? What is matter? Matter is a substance which has mass and occupies space. Matter is of two types, pure substances and mixture. Pure substances can be elemental form or in the form of compounds. Then what about mixtures? They are of two types, homogeneous mixture and heterogeneous mixture. Let us define what are elements. Pure substances which are made up of one single kind of atoms are known as elements. They cannot be further splitted into two different compounds or substances. So examples of these elements are iron, gold, silver, mercury, carbon, oxygen, nitrogen and sodium. See this picture. Gold is a solid element. It is a metal. It exists in the form of solid. Mercury is a liquid metal. Hydrogen and oxygen are the gases. These are all existing in the form of elements. Diamond, though it is of complex structure, it is just made up of carbon. Even if it is powdered also, you get only carbon. Coal, coal is also made up of carbon. Let us define compound, children. Compound is a pure substance made up of two or more elements combined chemically in a particular ratio. So if you want to separate the different elements present in the compound by the chemical method, you will be getting the same elements after the separation, isn't it? So it is also a pure substance. What are the characteristics of compound? The properties of compound are different from one compound to another compound, and it mainly depends upon the constituents, the elements present in the compound. The compound has a fixed melting point and boiling point. Children, the elements present in the compounds can be separated by some chemical process by using the energies. Like for example, water molecule is made up of hydrogen and oxygen. Then if you apply electricity, then by the help of electricity, by a method called as electrolysis, you can separate the elements present in the water molecule. What are the elements present in the water molecules? Hydrogen and oxygen. So this process is called as electrolysis. Electrolysis. Lysis means the breakdown of water molecule with the help of the electric energy into hydrogen and oxygen is called as electrolysis. So by using the chemical methods, you can separate the elements. Then is compound a pure substance or a mixture? It is a pure substance because here the elements chemically combine with each other to form a new substance. They are reacting with each other. So you are applying energy and you are separating the elements. So what are pure substances? Let us define it. They can be elemental form or compound form. They are made up of only one kind of entity. They further cannot be broken down into simpler entities by any kind of physical or chemical methods. They have a particular fixed composition. We have seen some examples, diamond and coal. So pure substances are existing in the form of elements and compounds. Then what about mixtures? Mixtures are homogeneous mixtures and heterogeneous mixture. Children, how can you form a mixture? How are these mixtures formed? By mixing different substances. Like here in this example, you can see we have taken orange pebbles, green pebbles, red pebbles, yellow pebbles. These all mixed together in a particular ratio, we see a formation of mixture. So let us define what is homogeneous mixture. A substance which has uniform composition throughout is called as a homogeneous mixture. For example, sugar, when it is added in water, what happens to sugar, children? It gets dissolved. How can you see it? It is seen in the form of a solution. Sugar loses its identity and combines with water. It gets dissolved in water and forms a clear solution. And so this solution is called as homogeneous mixture. Children, for example, this is sugar and this is crystal salt. Now I am mixing these two substances. Here you can see sugar gets mixed with crystal salt, but they don't lose their identity. You can easily identify which are sugar crystals and which are salt crystals, isn't it? So this type of mixture is called as heterogeneous mixture. Even this is an example of heterogeneous mixture. Here you can find different colorful gems and different types of dry fruits. So all these do not lose their identity even though they are mixed with each other. You can easily identify them based upon their color and shape. So let us see the differences between homogeneous mixture and heterogeneous mixture. All the compounds of mixture are uniformly mixed in homogeneous mixture. In heterogeneous mixture, all the components of mixture are not thoroughly mixed. You are easily able to identify them again even after mixing. In homogeneous mixture, no separate boundaries are visible. When sugar was added in water, you did not see any separate layers between the sugar and the water. Sugar got totally dissolved in water. In heterogeneous mixture, we can see separate boundaries. That is why you were able to identify which is a colorful gem and which is a dry fruit in the plate. Children, in homogeneous mixture, the sugar and water, they combined with each other in a form of a clear solution, and so it consists of a single phase. Whereas in a heterogeneous mixture, we can find many phases depending upon the different types of materials you have combined to form the mixture. So what is the example of homogeneous mixture we have taken, children? Sugar dissolved in water. What is the example of heterogeneous mixture, children? We have combined salt and sugar here. You can combine sand and salt or any two different substances you can combine. Now, air is also an example of heterogeneous mixture. Air is a combination of different gases mixed with dust particles also. So, air is a very good example of heterogeneous mixture. Children, mixtures can be classified into solution, suspension and colloidal solution. Let us define what is solution. In this example, we have seen sugar or salt, when it is completely dissolved in water, we get a clear solution. What is the type of solution we are calling it as? We call it as a homogeneous mixture. So a solution is a homogeneous mixture of two or more substances. You can take salt, when it is dissolved in water, we get a clear solution. Our earlier example we have seen mixing sugar with water. Now let us see what are the components of solution. The components of solution are solute and solvent. Solute is a substance which is taken in less quantity. Like here in this example we have taken sugar in less quantity and water in more quantity. So sugar is taken in less quantity, so it is a solute, and we have dissolved sugar in water. So water is taken in large quantity, so it is called as solvent. Let us define what is solvent. The component of the solution that dissolves the other component in it and is usually present in large amount is called as solvent. For example, liquids, we use water or alcohol or any other kind of solvent like ether, ammonia, benzene, etc. Children, solvent is taken in larger amount. Now what is solute? The component of the solution that is dissolved in the solvent and is usually present in less quantity. Children, in the earlier example, we have taken sugar dissolved in water. So, sugar was taken in less quantity, so sugar is called as a solute. So, for example, salt, sugar and whatever the substance is dissolved in the solvent in less quantity is called as solute. Now, let us study about solubility. Children, the amount of solute present in a saturated solution at a particular temperature is called as solubility of that solute at a particular temperature. So, solubility means what, children? The amount of solute that is present in a saturated solution. That means it cannot further dissolve some more solute. It has completely dissolved and no further solute can be dissolved in that particular solvent. Then that amount is called as solubility of that particular solute at that certain temperature. So, children, let us see what is solubility again. The amount of solute present in a saturated solution at a certain temperature is called as solubility of that solute at that particular temperature. So, it is the measurement of amount of solute present in the solvent, that the solvent has dissolved a certain amount of solute at a certain temperature. No more solute can be dissolved, and so that amount is called as solubility of the solute. Children, let us do this activity. Here we have taken 5 glasses of water. In the first glass, I have added little amount of ink. This ink is acting as a solute here, which is taken in the less quantity. See the color of the solution, children. It is light pink in color. Now let us add few more drops of ink in the second glass. See the difference in the color. The solution has become darker than the earlier one. Now add few more drops of color, children. What is happening? You can see the change in the color is taking place. This solution is more darker than the earlier solution. Now in the fourth glass, add few more drops of color, children. What happens? It becomes more darker than the earlier glass. So what is happening, children? Slowly we are increasing the amount of solute, and now in the fifth glass add more amount of ink drops. Then what happens? It becomes more thicker and darker than the other solutions. So you can see in this picture also there is a difference in the colors of the solutions. In the first glass we have taken only 2 drops of ink, and so see the color, children, it is light red in color. Now slowly when you have added more drops of ink in all these glasses, the color has changed. It has become more darker in the last glass. That means here more amount of solute is added, and that is why it is dark red in color. Whereas in this glass we have added less ink drops, and so it is light red in color. So this solution which has less amount of solute in it is called as dilute solution, and this solution in which we have added more drops of ink is called as concentrated solution. And so as the amount of solute increases, the dilute solution becomes concentrated solution. Let us define what is dilute solution and concentrated solution. If the amount of solute present in the solution is less, then we call the solution as dilute solution, and if the amount of solute present in the solution is more, then we call it as concentrated solution. Children, based upon the solubility, we can differentiate the solutions into 3 types: unsaturated, saturated and supersaturated. Unsaturated means what? So we know that solubility is the amount of solute present in the saturated solution. So saturated means what? It has sufficient amount of solute particles in it. It cannot further take any more solute particles. So after some time you can see the solute particles, they keep settling down here. So solubility is the amount of solute present in this solution. No more solute particles can be added. So what is unsaturated? If the solute present in this solution is less than the solubility, then we call it as unsaturated solution. Then what is supersaturated solution? If the solution contains more amount of solute than the solubility, then you can see if you keep on adding sugar crystals, they keep settling down at the bottom. Then such a type of solution is called as supersaturated solution. Let us define what is it. Saturated solution means a solution in which no more quantity of solute can be dissolved at a particular temperature. That type of solution is called as saturated solution. Unsaturated solution means what? You can add more quantity of solute and you can dissolve it by raising the temperature. Children, here such type of solutions is called as unsaturated solution. Then what is supersaturated solution? A solution in which more amount of solute is present than the solubility of the particular solute, then that type of solution is called as supersaturated solution. What happens if you increase the temperature? Children, in this cup, the sugar crystals are settling down at the bottom. That means this is supersaturated solution. If you add hot water in this, or if you increase the temperature of this cup, then what do you think it happens? Yes, the sugar starts dissolving because you have increased the temperature. See children, the total sugar has completely dissolved. In this also the total sugar has dissolved. You can add further more sugar in this. So this is unsaturated solution, this is saturated solution, and this is supersaturated solution because you can see furthermore crystals present at the bottom of the cup. If you add hot water in this, then what happens? The sugar starts dissolving because we have increased the temperature of the solvent. What are the conditions affecting the solubility? The very important condition is temperature. As the temperature increases, the solubility of the solute in the liquids will increase. That means you can further increase the amount of solute added in the solution by increasing the temperature. The concentration of a solution can be represented in many ways. First one is mass percentage, mass by mass percentage, mass by volume percentage, volume by volume percentage. Children, let us define what is concentration. The concentration of a solution can be defined as the amount of solute present in the solution in grams present in 100 grams of solution. This is called as mass by mass percentage of a solution. So mass by mass percentage of a solution is obtained by a formula mass of the solute by mass of the solution into 100. So as we are finding the percentage of solute present in the solution, obtaining this formula mass of solute by mass of solution into 100. Let us do one example children. If you make a sugar solution by adding 25 grams of sugar in 100 grams of water, then how will you find out the percent by mass? By the help of a formula. Now how much is the amount of solute present in the solution? We have taken 25 grams of sugar, we have taken 100 grams of solvent. So what is the total amount of solution? 25 plus 100, that is 125 grams. So mass by mass percentage of a solution can be obtained by formula mass of the solute by mass of the solution into 100. Now substitute these values. Percent by mass is equal to 25 by 125 into 100. This comes to 20%. So what is the concentration of sugar in this solution children? 20% sugar solution. We call it as 20% mass by mass percent of solution. Mass by volume percentage. The concentration of a solution can be defined as the amount in grams of solute present in 100 ml. As I told you, it is mass by volume percentage. So we are taking the volume of the solution consideration. What is the formula? Mass of the solute by volume of the solution into 100. So mass by volume percentage of a solution can be obtained by formula mass of the solute by volume of the solution into 100. Let us do one example. If a solution is prepared by taking 10 grams of salt in enough water to make 150 ml of solution. Then the mass volume concentration here is given by the mass volume concentration formula. Mass of the solute we have taken here is 10 grams of salt, and the volume of the solution totally we have obtained is 150 ml. So what is the formula of mass volume concentration? Mass of the solute by volume of the solution into 100. Now let us substitute the values in this formula. 10 grams of solute by 150 ml of solution into 100. This comes to 6.7% mass volume concentration of salt solution. So 6.7% of salt is present in the solution. Children, another parameter to measure the concentration is volume percentage. So the concentration of solution can be defined as the volume of solute present in 100 ml of solution. The volume by volume percentage of a solution can be defined as volume of solute by volume of solution into 100. Let us do one example. If you are making a solution by using 40 ml of ethanol and adding it in enough water to make 240 ml of solution, then what will be the percent by volume of solution? Volume of solute we have taken here is 40 ml of ethanol. Volume of solution totally we have got is 240 ml, and so volume by volume percentage of a solution can be obtained by formula volume of solute by volume of solution into 100. Let us substitute the values. 40 by 240 into 100, that gives rise to 16.7% volume by volume percentage of ethanol solution. So children, did you understand how to find out the concentrations of the solution? Now let us come to the other type of mixture, that is suspension. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended in the medium. Children, the solute particles, they settle down when a suspension is left undisturbed, but in the mixture it usually solute particles, they keep suspended themselves in the medium. So they cannot be separated from the mixture by filtration. For example, if you take chalk powder and dissolving it in water, then the chalk powder will not dissolve. Then what happens? It settles down after some time. But if you keep mixing it, the chalk piece powder, it keeps suspended itself in the water. This is an example of suspension. Now if you add oil in water, they do not dissolve in water. Oil keeps suspended itself in water. This is also an example of suspension. Children, now let us come to another type of mixture, that is colloidal solution. A colloidal solution is also a mixture. In this, the substances are regularly suspended in the fluid. They can be classified into different types. Let us see the examples here. Before going to the examples, now let us study about the two phases present in the colloidal solution. One is dispersed phase and the other one is the dispersion medium. Children, dispersed phase means the solute-like component of the dispersed particles in a colloid forms the dispersed phase. Dispersion medium means what? The component in which the dispersed phase is suspended is known as dispersing medium. That means the solute-like particles are called as dispersed phase and the solvent is called as dispersing medium. So children, let us come to the first type of colloidal solution, that is foam. Children, if you add a little amount of surf in the water and shake it for some time, you get foam. What is foam here? Air particles, they start getting suspended in the water. So here water is the solvent and the air bubbles are the dispersed phase. So a colloidal solution with dispersed phase gas at dispersing medium, solid or liquid, is called as foam. For example, shaving cream, clouds, we keep seeing it daily. How are these clouds formed? When water vapor, it gets accumulated in the condensed state in the air, then we call it as a cloud. So water vapor is the liquid phase and it is called as a dispersed phase here. It is getting suspended in the air. So we call it as aerosol. A colloidal solution with a dispersed phase solid or liquid and the dispersing medium gas is called as aerosol. So what is the example of aerosol, children? Clouds. Children, one more example here is sol. Another type of colloidal solution here we are taking is sol, S-O-L, sol. A colloidal solution with the dispersed phase solid and the dispersing medium liquid is called as sol. For example, milk of magnesia. When magnesium hydroxide is added in water, then we get a solution called as sol. It will not completely dissolve in water, and so we can see it forms a colloidal solution. Another example is, take some mud and dissolve it in water. You can see the mud particles are suspended in the glass. So a colloidal solution with the dispersed phase is solid. Mud is solid, so dispersed phase is solid, and the dispersing medium is liquid, that is water is liquid. It forms a colloidal solution called as sol. So example here we have taken as mud in water. Now emulsions. These emulsions are formed when two liquids are combined with each other in a particular ratio. Children, the dispersed phase is liquid and the dispersing medium is also liquid. Then it forms a solution, colloidal solution called as emulsion. For example, milk. So we have seen so many examples, children. Dispersed phase and dispersing medium are given in this table. Dispersed phase if it is liquid and the dispersing medium if it is gas, then it is aerosol. Examples we have seen: fog, clouds, mist. Dispersed phase if it is solid and dispersing medium if it is gas, then it forms aerosol. Examples: smoke, automobile exhaust, etc. If the dispersed phase is gas and the dispersing medium is liquid, then it forms foam. Example: shaving cream. Dispersed phase is liquid and the dispersing medium is also liquid, then it forms emulsion. Example: face cream or cold cream. Dispersed phase if it is solid and the dispersing medium is liquid, then it forms a sol. Example: milk of magnesia. If the dispersed phase is gas and the dispersing medium is solid, then it forms foam. Example: foam, rubber, sponge, pumice, etc. If the dispersed phase is liquid and the dispersing medium is solid, then it forms a gel. Example: jelly. If the dispersed phase is solid and the dispersing medium is also solid, then we get a solid sol. Example: the glasses. Now let us see very important effect which is mostly seen in the colloidal solution, that is Tyndall effect. See this picture, children. In this picture we can see a forest through which the sun rays are entering. You can see the sun rays are getting scattered. When the sunlight enters into the forest, we find so many dust particles. These dust particles, they are suspended in the air, which forms a colloidal solution. And so this dispersion causes an effect called as Tyndall effect. Children, observe this picture, children. We have taken a light source. When this light source is allowed to pass through the clear solution, can you observe this light ray passing through the solution? No, because this is a homogeneous mixture. So the light ray or the beam of the light ray cannot be seen in this passing through the solution. But in this class we have taken a colloidal solution. Colloidal solution means what? Here we have taken a drop of milk added in water. So you can easily see the light ray passing through this colloidal solution and you can observe that it is getting scattered. You can see the dispersion of the light ray here. Now this is a suspension. You can see flour and water has been mixed in the solution. When the light ray is passed through it, the light ray is getting scattered. You can see the light ray has become wider. So let us define what is Tyndall effect. Tyndall effect is the scattering of the light ray in a colloid, or else the particles in a very fine suspension. That means here the scattering of the light ray or the light particles is taking place due to the particles present in the colloid or the suspension. So what is the example we have seen, children? We have seen the sunlight when it is passing through the dense forest. You can see the light ray is getting scattered. The light ray is getting scattered. So this effect is called as Tyndall effect. Now let me ask you a question. Is ice cream a colloid? Now let us summarize what we have learnt. Children, pure substances which are made up of only one kind of atoms, like elements or compounds. The amount of solute present in a saturated solution at a certain temperature is called as the solubility of that solute. We have studied about a solution. It is a homogeneous mixture. We have studied about Colloidal solution, it is a mixture in which the substances are regularly suspended in the fluid. Now answer these questions and improve your learning, children. Explain the following with examples: saturated solutions, pure substances, colloidal substances, and such. Children, you can download the worksheets from SIET website for better learning and good practice. I hope you have understood the lesson. Now in the next lesson, we will be learning few more concepts of the topic. So see you soon again in the next digital class. Thank you.